Welcome to tonight's video on section 2.6, talking about rational functions and how to graph rational functions. Remember, a rational function is the quotient of two polynomials. So if we have p of x and q of x, and they're polynomials, when we divide them, we can make a rational function. For example, like x squared plus 4x plus 4 over x plus 3. That's a rational function because it's got two polynomials and you're dividing. To find the domain of a rational function, remember, since it's a fraction, that the denominator cannot equal 0. So basically, to find the domain, you set the denominator equal to 0. So in this case, x minus 3 equals 0, so x cannot equal 3 for this function. So your domain would be all real numbers except for 3. So you'd say negative infinity to 3, union 3 to positive infinity. For part B, if you factor this, you get x plus 3 and x minus 3. So when you set those equal to 0, notice you get x equals negative 3 and 3. Those are the two numbers that it cannot equal. So if you do your number line, here's negative 3, here's 3. So remember, it's from negative infinity to negative 3, from negative 3 to 3, and from 3 to positive infinity. And that is your domain. Now here, you set x squared plus 9 equal to 0, and notice you get x squared equals negative 9. And that is not, and if you looked at just x squared plus 9, it's not factorable, which means there is not any number that I cannot put in for x. So therefore, it is all real numbers. And remember how you write all real numbers in an interval from negative infinity to positive infinity, because there's not a number that I could put into the bottom that would make it equal to 0, because it's impossible to square a number and get negative 9. The vertical asymptotes occur where the denominator is equal to 0. And those are points on a graph that basically, that's where the graph cannot cross. So locating vertical asymptotes, like I said, you want to set the denominator equal to 0. So, for example, in the first one, it says to find the vertical asymptote, question. So to figure out how to find the vertical asymptotes, first we're going to factor the numerator and the denominator. And we're going to simplify if possible. And then step 2, we're going to set the denominator equal to 0. And it's important you factor and simplify because some of these you can simplify. For example, the bottom here, it's x minus 3 and x plus 3. Now we can't simplify here top and bottom, so what numbers make the bottom equal to 0? So x minus 3 equals 0, x equals 3, x plus 3 equals 0, x equals negative 3. So our two vertical asymptotes are x equals 3 and x equals negative 3. Because remember, vertical asymptotes are a line that the graph does not cross, a vertical line. The next one, if you notice when I factor it, I have x plus 3 on the top, and I factor and I get x plus 3 and x minus 3. Notice that the x plus 3's cancel out, and now I'm left with 1 over x minus 3. When I solve the denominator, notice I just get x equals 3, and that is my vertical asymptote. For this one here, notice I cannot factor the denominator. X squared plus 9 does not factor. So in this case, since there's no number also that if I set it equal to 0, I can't square a number and get negative 9, that means there are no vertical asymptotes because there's no number that I can put in to make the denominator equal 0. Horizontal asymptotes, if you have a rational function, and remember we've defined a rational function as p of x over q of x, and the degree of the numerator is n, so the degree of p of x is n, and the degree of the denominator is m. So for example, if I had 3x squared plus 5x plus 2 over x minus 1, the degree of the top, or the numerator, would be 2, and the degree of the denominator would be 1. Because remember, degree is highest power of x. So horizontal asymptotes are based upon the degree of the numerator and denominator, and you compare them. If the degree of the numerator is less than the degree of the denominator, that's part 1, the x-axis, or y equals 0, is the horizontal asymptote. So for example, if I had x minus 3 over x squared plus 2x plus 1, see, degree is 1 here, degree is 2 there. So if the degree of the top is less than the degree of the bottom, the horizontal asymptote is y equals 0. Number 2, it says if the degrees are the same, so for example here, if you had 3x squared plus 2x plus 1 over x squared minus 9, notice the degrees are the same, then you take the leading coefficients of each one, so in this case 3 and 1, and you divide them. So your horizontal asymptote in this case would be y equals 3 over 1, which is 3. So y equals 3 would be the horizontal asymptote. The last case is when the degree of the top is bigger than the degree of the bottom. So for example, if we have 3x to the third plus 4x over x squared minus 9. Notice degree of the top is 3, degree of the bottom is 2. So if degree of the top is bigger than the degree of the bottom, there is no horizontal asymptote. So in these examples here, they want us to find the horizontal asymptotes. So, and notice the degree of the top here is equal to 1, the degree of the bottom is equal to 2. So when top degree is bigger than or smaller than bottom degree, you know the horizontal asymptote is y equals 0. Here the degree is 2, here the degree is also 2. When they're the same, you divide the leading coefficients. So the horizontal asymptote in this case is 4 over 2, which simplifies to 2. So it's y equals 2 as the horizontal asymptote. The last one, notice the degree is 3 on the top, degree is 2 on the bottom. So notice, since the degree of the top is bigger than the degree of the bottom, there is no horizontal asymptote. We'll talk more about how to graph these asymptotes in the next video, but for now we just want to be able to find them so that when it comes time to graph them, we can do that. So there's two types, remember, there's horizontal and vertical. Horizontal, you look at the degree of the top and the degree of the bottom and compare. Vertical, you set the denominator equal to 0 after you've simplified and factored. All right, hope you had a good evening, and I will see you guys tomorrow in class.